Okay, we're going to do our last gravimetric analysis problem today. I think four is enough. That should give you a good feel for them. And if you want to, go deeper into it, there's a lot of things on AP Central you can look up, or I have some other problems on my other YouTube channel as well. So let's do number four here. A teacher gave their students an 8-gram tablet that contains magnesium nitrate, MgNO32. They give us a formula and a molar mass here, so that's pretty convenient. In order to determine the percentage of magnesium nitrate in the tablet, the students dissolved the tablet in 100 milliliters of distilled water and added excess sodium phosphate. And so when we're talking about adding excess, we add till we can't see any precipitate forming, and then we add a little bit more. After a precipitate is formed, the students filter, wash, and dry the precipitate to completion. Again, they're not asking us anything about the steps, with the drying. How do you know that the precipitate is, fully dry or anything like that? And it's when the mass, stops changing. The precipitate is measured to have a mass of 3.524 grams, and so note the precipitate will have a molar mass of 262.84 grams. So what they're telling us here is we know that the precipitate is not going to be magnesium nitrate. It's going to be something else. So write a balanced net ionic equation for the chemical reaction of the formation of the precipitate. I added some words there, but once you're in, you're in. You got to keep going. And so this should be old hat for us now, right there. And so there's our magnesium nitrate, and we're going to be reacting that with sodium phosphate, and then here is what I'm making, because sodium nitrate, as we've discussed, anything with sodium is going to be soluble, and anything with nitrate soluble. So sodium nitrate is soluble in 2 counts. So this right here is going to be our precipitate. And so I bust everything up into ions. And if you look, the nitrates, even though I had to kind of squeeze it in there, are the same on both sides. The sodium is the same on both sides. Now notice I did balance. Those odd looking things are 6s, because in order to make Mg3PO42, a phosphate's a -3, and magnesium, because it's in that second column of the periodic table, is a +2, and so +2, 2, 2, 2, 6, and then -3 is -6. That adds up, and then you need to have the charges balance with everything in the reaction, and so that's why we have, I've lost it and now I found it. 6 here and 6 here, because the overall charge to get our right formula is going to be +6, because we need 3 of those magnesiums and 2 of the phosphates. So to balance that out, we need 6 sodium, which is a +1, and 6 nitrates, which it just happens to be a -1. That's why we need 6 of both of them. Okay. So let's look at B here. Calculate moles of the precipitate. Well, that's pretty easy, because they tell us what the mass of the precipitate is. And so I just take the mass of the precipitate, and what I meant to say was they tell us what the molar mass is. And if you add that up, that's another indication that we're making that magnesium phosphate, that Mg3PO42. And so when you add that up, it's going to give you the number, but you don't need to do that because they've told us you do need to put 1 mole in here, and that gets us 0.0134 moles of or 01341, because I'm keeping my 4 sig figs from here to here. Okay, and I've found places where you can get this worksheet done on the internet, but I'm gonna go ahead and tell you, don't trust a lot of stuff on the internet, because the thing is, they're not taking care of their sig figs, and that's going to be an important part of the work we do in uh, AP Chem, and also just when you're working in the lab yourself, you want to take care of those numbers, and you want to give the best data that you can, and just kind of go on a blanket 2 to the right of the decimal or something. That's doesn't work. It doesn't work in real life, and it doesn't work in the class. But that's beside the point. So we have our moles of precipitate, determine the moles of magnesium nitrate. Now here's where we get into our actual stoichiometry and our gravimetric analysis. So I take the moles of the precipitate, and then in 1 mole of that precipitate, because I have that little 3 by the magnesium, I know that there are 3 moles of magnesium. So in order to make 1 mole of magnesium phosphate, I need 3 moles of magnesium. Mg3PO4 2. So I need 3 moles of magnesium and 2 moles, that hurt my finger, 2 moles of phosphate. And so it's 3 moles of magnesium, because the reason why I picked magnesium and not phosphate is magnesium is going to be in that magnesium nitrate that we need. Okay, and so so here I've switched to magnesium, and then in my magnesium nitrate, which is my final, that's what I'm really looking for, there's only 1 mole of magnesium. So you see the magnesium crosses off with the magnesium phosphate crosses off with the magnesium phosphate, and it's not that hard, but I can see where it does take steps, and it's providing a lot of evidence here. And so here we are at 0.04023, and that first 0, even though we have it there, that's a placeholder. And remember, if you get confused, write it as a scientific notation number, and then that 0 wouldn't be there. And you would notice that, that's a placeholder, and we keep the next 4, okay? And so there's that. Get a close-up there. And then you've already probably got D. Calculate the mass of magnesium nitrate in the tablet. And so there, again, I'm keeping those 4 sig figs. And then now here I switch to 3 sig figs, because when they ask for the percentage of magnesium in the original tablet, they give me 3 sig figs. So I got 4 here, 3 here. You always go with the less number, so you keep your 3 and times that by 100 to get that percentage, and it is 74.6%. And that's not a bad problem. We can handle problems like that.